Hi, it's Paul Anderson, and in this video I'm going to go through the basics of the urinary system. The major organs in the urinary system are going to be the kidneys, and their major role is in waste excretion. They're cleaning our blood, and solid waste from the blood is eventually going to leave our body as urine. Now, in addition to doing that, they also regulate blood volume, blood pressure, blood pH. They regulate important electrolytes and metabolites in our body. The kidneys are incredibly important. Without them, you'll die unless you're hooked up to a kidney dialysis machine. But that's going to require going 3 times a week, 4 to 5 hours a day, hooked up to a machine just to clean your blood. Now, in addition to the kidneys, we also have other parts of the urinary system, including the ureter, the bladder, and the urethra. In males and females, the urinary system is essentially identical, except for the length of the urethra itself. Now, what's the role of the kidney? The role is to produce urine. From there, it's transported to the bladder through the ureters, and then from there it's stored and eventually conducted into the environment. That's how we lose this waste. Now, you might be thinking to yourself, what is urine? Well, urine is mostly water, so 90 to 95% of urine is going to be water, but the rest of it is going to be solid waste, both inorganic and organic. Organic waste like urea, uric acid, and inorganics like toxins and certain salts as well. If we look at the structure of the kidney, on the outside we're going to have the renal cortex. Renal simply means kidney. So we've got the outer layer of the kidney, and then on the inside we have the renal medulla. And then on the center we have the renal pelvis. This is going to be a hollow opening, and this is where all the nephrons are going to enter into. They're going to get rid of their urine, and that's eventually going to go through the ureter. Now, if we look inside the kidney itself, we find the whole thing is just filled with blood vessels. Around 20% of cardiac output is going through the kidneys. So that's a massive amount of blood that's going through the kidneys. How does it do that? Well, it comes in through the renal artery, out through the renal vein, but there's a huge amount of surface area inside the kidneys itself. From there, we go into smaller arteries, and then arterioles and capillaries, and then eventually the blood is going to come out. But the important waste excretion is going to take place as we get to those center blood vessels. So let's zoom into that, and let's zoom into the functional unit of the kidney, which is going to be the nephron. So if we look at where these blood vessels are found, blood's going to flow into the nephron through the afferent arteriole, and then it goes into the glomerulus, or the glomerular capillaries. At this point, you essentially have a dead end. The blood is flowing in, and it comes to a dead end. That dead end is inside something called the Bowman's capsule. At this point, we're going to have filtration occurring. A lot of that blood plasma is squirting out of the capillary, and it's eventually going to move into the urinary system. From there, the blood goes through the afferent arteriole. And so at this point, we've got filtration taking place. This is where we're actually filtering the blood. Now, if you look at the blood vessels, they continue to go and wrap around the rest of the nephron, the peritubular capillaries, before they're eventually going to leave. What's going on all of this surface area is secretion and reabsorption. Secretion is when we're taking material that's in the blood that wasn't filtered out, but we're getting rid of that. And also there's some material in the filtrate, glucose, water, for example, that we want to reabsorb. So we're going to take that back into the circulatory system. So if we remove the circulatory system, now we can kind of see what that nephron looks like. First part's going to be the renal corpuscle right here. If we look at what's taking place there, that's where that filtration occurs. So at this point, we call this a filtrate. From there, it's going into a number of different renal tubules. The first one is going to be the proximal convoluted tubule. Proximal means close to the renal corpuscle. Convoluted means it's just folded over and over in many different dimensions. We're increasing the surface area there. What's going on at this place is that we're reabsorbing important material. We're reabsorbing solutes, water. We're taking that back into our circulatory system. From there, the renal tubules are going to flow down into what's called the loop of Henle. We have a descending limb of the loop of Henle, and during that, we're reabsorbing a lot of the water. And then as we have the ascending limb of the loop of Henle, we're reabsorbing a lot of that sodium and chloride, a lot of that salts are coming back into our body. If we look at where we are inside the kidney itself, as we go down into the loop of Henle, we've entered into that renal medulla. And if you think about what's going on as we move farther and farther down, we've set up a countercurrent exchange. What we're doing is we're increasing the salt levels as we move farther and farther down into that renal medulla. That makes it easier for us to take back more of that water in the descending limb of the loop of Henle and also in the collecting duct. From there, we're moving into the distal convoluted tubule and then into the collecting duct. If you think about where this collecting duct is going, you can see that we're getting a bunch of other nephrons that are connected to it as well. From here, it's eventually going into that center of the kidney, the renal pelvis, and eventually it's going to leave as urine. Now, what's going along in that distal convoluted tubule and the collecting duct is we have variable secretion and reabsorption of solutes and water. So in other words, sometimes we're getting rid of waste and sometimes we're taking that back into the body. Now, a lot of this is under hormone control. So for example, a really important hormone is vasopressin or ADH, antidiuretic hormone. And what that's going to do is it's going to affect the distal convoluted tubule and the collecting duct itself. And what it does is it essentially shuts down the flow of water outside our body. And so we can get a signal. If we sense how much water there is in our blood, we can get a signal that means we have to hold on to that. Or we can have a signal that says we want to release that water and it's eventually going to leave as urine. If we look at where it goes, from here, all of that waste that comes out of the nephron is emptying out eventually into the pelvis, into the ureter, and it's stored in the bladder itself. From there, we can eventually conduct that to the environment. And so that's how the urinary system works. It's really simple. It's also really, really important, and I hope that was helpful.